Hello, this is the Universal Mind Channel. Welcome. And this is part 9 of our study of reincarnation, the scientific theory. We're going to talk today about memory encoding, the research that we rely upon. And we didn't just dream this up. This theory is based upon the work of dozens, if not hundreds, of scientific researchers all around the world. They're cited in the book, and we cite them at the research that we rely upon for each of these episodes is cited in the description. So if you have any questions about it, if you have any questions, any doubts about the validity of this theory, I don't know why, because it's based upon science, folks. You can try to smoke and mirrors something, but when it comes to scientific research that you can pinpoint and say, this researcher discovered this, and it's not only applicable to what he's studying, but it fits in like a puzzle to what other researchers have come up with. And even though they're not aware of how all the pieces fit, that's understandable because they're stuck in their own little niches, their narrow little parameters within which they work. A generalist like myself has an opportunity to take a look at all of that, and that's exactly what I did. And excuse me if I was able to put all the pieces together. I don't pat myself on the back much, but it is what it is. I don't know anybody else that's been able to develop a scientific-based theory of reincarnation. It's not faith when you can cite, it's not merely faith, if you can cite scientific research that shows every step of the way of a certain process is scientifically valid. And that's what we've done and are doing. So let's get going on memory encoding. Basically, memory encoding is you've got the ion bound memories, all right, and then you've got the body having biophotons. So let's take a look at the components required for memory encoding. 1, the ions containing the memories. 2, a place within the limbic system, because that's where all this activity is going on. The gray matter, white matter of the brain may already be dead in the dying body, but the core of the brain, where the limbic system is still functioning. And remember, this takes place within a second, a few seconds. That's all that's necessary, because we're dealing with photons that can travel, that not only can travel, but do travel at the speed of light, that fast. So we have the ions containing the memories, number 1. Number 2, the place within the limbic system where the memories can be successfully encoded. Where is that? And 3, do we have a transmission medium upon which the memories are to be emitted out of the body? Are the memories, is there something the memories can be bound to, encoded upon, so that this package, this packet, can then be emitted? And understand, the packet is an elementary particle, so small you can't see, like a photon, like a biophoton. It's a hint. So, how the ion-held memories are likely prepared, we've already discussed in a previous episode. Encoding of ion-held memories must be an electrochemical process. It may be the same principles of simple photography, or something more complex such as magnetic resonance imaging, MRI. Whatever the process, it must be natural to the physiology of the brain and require little time and energy. A dying person would have little left of either. By this time, the gray matter and white matter of the brain may already be dead. And the only part of the brain still alive may be the brain's core, where the limbic system is located. The location within the limbic system responsible for encoding the memories for transport out of the body must be free of electrical activity that might create electrical interference with phi alpha encoding. And remember, we're not using the term reincarnation anymore. We're referring to it as phi alpha. Scientific processes deserve scientific names for serious scientific study. And it's time we did that. We got to grow up, folks. Such an area would need to be structured such as to readily secure the memories in place for stable encoding. It would also need to be relatively free of cellular activity of its own, a relatively electrochemically free zone within which the encoding could take place in the same way a darkroom is necessary to develop photographic film. Limited interference may be tolerable, though, as cellular activity throughout the brain at this stage of death would most likely be greatly reduced or even absent. One such area of the brain fits all these criteria. The hippocampal sulcus, S-U-L-C-U-S. It's a small fissure or pocket that lies within the hippocampal formation near the amygdala. The hippocampal sulcus has the two qualities needed for phi alpha memory encoding. First, its pocket-like shape can readily hold and stabilize the ion-held memories while they're being encoded upon the transport medium. Second, being relatively free of cells itself, the hippocampal sulcus provides an area relatively free of any electrochemical activity that might interfere with the phi alpha encoding. The hippocampal sulcus is the brain's own little darkroom. The pocket inside the fold provides the compactness necessary to force the biophotons and the ion-held memories together. As the biophotons and the memory ions merge, there's a brief flash of light, as the memories are bioelectrically transferred, like a photograph, from the ions to the biophotons. Once the memories are flash encoded upon the biophotons are released and travel out of the body. And that's in essence what emission is. The ion-held memories prioritized in the amygdala wouldn't have to travel far to reach the hippocampal sulcus, as the hippocampus lies just below the amygdala. The ions would be held in place by the pocket-like formation of the sulcus long enough for the hippocampus to discharge a flash of biophotons from the surrounding sulcus cavity. This, we suspect, is the cause of the sudden intense EEG burst observed by emergency room doctors treating patients who have near-death experiences. This flash of biophotons would extend throughout the surrounding hippocampal sulcus tissue, essentially creating a holographic image of the memories stored within the ions. This 360-degree flash would have the added effect of encircling the ion-held memories in a self-contained state of energy and data coherence necessary for survival during the emission out of the body. It's a protected packet of biophotons carrying these memories that have been encoded within the hippocampal sulcus. Biophoton emission in humans has become an exciting area of study in recent years. A growing body of evidence suggests, that photons play an important role in basic functioning of cells. Cells emit light when they work and use light to communicate with each other. Photons may also play an important role in neural functioning. Spinal neurons of rats have been found to emit light. Microtubules inside the brain may act like optical fibers, conducting photonic information. In addition to electrical and chemical signals propagating in the neurons of brain, signal propagation also takes place in the form of biophotons. Experimental confirmation of photon guiding properties of a single neuron have been documented by researchers. Interaction between biophotons and microtubules in the brain may cause transitions or fluctuations of the tubules between coherent and non-coherent states. The role played by biophotons inside the brain is an exciting new area of biophysics that merits special study. As Professor Majid Rahnama of Shahid Bahanar University suggests, quote, these interactions involve long-range ionic wave propagation along microtubule networks, MTNs, and action filaments, AFs, and exhibit subcellular control of ionic channel activity, unquote. They explain how biophotons help support coherent energy states and show how the interaction of quantized field with a system of electric dipoles produces what's called a state of coherent energy. They believe microtubules can be considered biological electrical dipoles. Other researchers have also confirmed the presence of biophotons in both living and deceased human brains. Professor Joey Caswell, C-A-S-W-E-L-L, and his team instructed human subjects to employ intention and effort to affect the direction of a random number generator within a special device located within 1 meter of the test subjects. With this device, biophoton emissions with the brain's right hemisphere were recorded simultaneously with each of the subject's thoughts. Caswell and his team discovered that when human test subjects attempted to affect the numbers produced by the random number generator, their brains experienced a significant increase in photon emission. What's a random number generator? It's a computer that creates random numbers. And it sits there creating random numbers. That's all it does. And what this team of researchers did, they put subjects next to this number generator and had the subject think of numbers and impact what this random number generator was coming up with. Caswell and his team discovered that when human test subjects attempted to affect the numbers produced by this random number generator, their brains experienced a significant increase in photon emission. The researchers concluded that intentional thought patterns were directly responsible for these photon emissions. In other words, the researchers were able to conclude that the human brain emits photons as a normal process of its functions. The interrelationship between the hippocampus and biophoton emission has been well documented by independent teams of scientists. It's not make-believe. Nicholas Rouleau, R-O-U-L-E-A-U, of the Biomolecular Science Program at the Laurentian University in Sudbury, Ontario, Canada, measured biophoton counts that exceed background flux densities from hippocampal tissue slices of the brains of human test subjects engaging in specific thought processes. In a separate study, Rouleau found human hippocampal brain region specimens possess the ability to emit biophotons even 20 years after death. That's astounding. 20 years after death. That makes you wonder what death is. You've got biophotons being emitted out of a dead brain 20 years after the body has allegedly died. What is death? We don't understand it. The life process, existence, we don't understand it. Lastly, a 2016 study found that glutamate-induced biophotonic activities and transmissions in the brain present a spectral redshift from animals, bullfrog, mouse, etc., lower animals, to humans, even up to the near-infrared wavelength in the human brain. This increase in photonic activity in the human brain, they believe, may partly explain the high intelligence of humans because photons are a more efficient communicator than electrochemical processes. The subject of quantum mechanical processes within the brain has been an area of ongoing scientific debate for decades. But now that biophoton emission from the brain has been actually observed and studied, there can be no longer any debate. It's been proven. The brain emits biophotons continuously as part of its normal everyday functioning. The conclusion that the human brain is a continuous source of biophotons as the result of electrochemical, electromagnetic processes is in fact startling. Even more startling, however, is that this biophotonic behavior opens the door to the mind-blowing reality that the human brain is an organic quantum mechanical machine. Brain physiology creates a quantum mechanical energy state and uses this quantum energy to function in ways we have yet to imagine. That's all for today. We'll be back later to discuss and go over memory emission. Thank you. If you have any questions about this episode or other episodes, don't hesitate to contact us at the Universal Mind Channel at gmail.com. The Universal Mind Channel at gmail.com. Thank you. Have a good day.